Question 6. So this is a probability question that can be solved using the TZ1 diagram. So we have two events. This will be the event A, and we have another event that will be B. And I know to sketch them like that because we know there's an intersection for A and B. This is the intersection between them, and it is given as X. So the probability for the intersection of the two events A and B is X. Additionally, we have that the probability of the intersection of A and the complement of B. So this is everything that is A and not in B. So this is just this part, and this is 0.16. And now for the second thing that is given, we have the probability for the complement of A intersection with B. So everything that is in B and that is not in A. So this will be this. This is 0.36. Now we need to find X, and we know that A and B are two independent events. This means that the probability for the intersection of A and B equals to the multiplication of the probabilities PA times PB. And now we can just create an equation based on that. So the probability of the intersection is X. This is given. The probability for A is 0.16 plus X. Yeah, so 0.16 is just that, but we have another small section here, the intersection between them, that is X. And the probability for B is 0.36 plus X. So this is a quadratic equation. We can solve for X. We are going to get X squared. So I'm using the calculator for some of the steps here. Minus 0.48x plus 0.0576. So now we can simply use the calculator to solve this quadratic equation. I noticed here that this is actually a binomial expression, and it can be closed to x minus 0.24 square. So I just noticed here this 576 that it have a square root of 24, and therefore x equals 0.24. So this is the answer for A. Now B, we have to find the probability of the complement of A given the complement of B. So first of all, when we have this kind of conditional probability, there is a formula that we can use. It is in the booklet, and this equals the intersection of the two events here, A prime intersection B prime, over the probability of the given event. So this is B prime. And now, in order to have numbers for those probabilities, we're going to use the Venn diagrams again. So we had A and B, and we know that this was 0.16, and this was 0.36, and the intersection, that was x, and it was 0.24. Now I need the intersection of A prime and B prime. So everything that is not in A and the intersection with everything that is not in B. So let's add here another so I corrected my drawing here so it will be easier to see. So everything that is not in A is basically all the outside, and including also maybe it would be better to use some color here. So A prime, everything that is not in A. And B prime, everything that is not in B. And we need their intersection. So the intersection is just the outside. Everything that is not in A and everything that is not in B, it's just the outside. And how we can calculate this outside. So we know that, let's write it here, P outside, it would be, we take everything that we have and we do 1 minus that, because the sum of all the probabilities is 1, and for the probabilities of A, B and their intersection are known, and this will be 0.24. So now I know this number for the intersection of A prime and B prime. And now I need the probability of B prime, so everything that is not B. Everything that is not B, it's the outside, so it's 0.24, but it's also 0.16. This is everything that is not B. This is B prime. And now we just have to do the division here, and I'm using the calculator, get that this is 0.6. So this is the answer for B.